test.
Okay. Some of us that are BBC, we are not learning it. All right. So today we will talk about a very important part of the lesson, that is about STARS inference hypothesis testing. How we test hypothesis, the most important things to look out for, why we need to test hypothesis, and then what to do and what not to do when we are testing hypothesis. So today we're going to talk a little on hypothesis testing, the test that we need to conduct for hypothesis testing, and then what we basically need to do. So today it's going to be lesson today for us.
Doctor, I think your voice is too low. Or is it on my end?
My voice is too low?
Yeah. Or is it on my end?
Is everybody okay?
Oh, it's now okay.
Okay. All right. So I was saying that we are going to have today it's basically hypothesis testing per our week plan, hypothesis testing. And I don't know, I was thinking to do a regression analysis before we go for hypothesis testing. But since it is a schedule, we go by it. All right. Now, by the way, can somebody just help us what hypothesis means? What is hypothesis? Everybody is a researcher on this platform. Everybody, every Tom Harry is a researcher. Madam Joanne, are you there? Is Madam Akofa MFA also on the page?
Yes, please, I'm here.
What of Madam MFA? She isn't here. All right. Since the record will be put on there. All right, so I'm going to share my screen now, and then we talk about this thing. By the way, anybody to help us what hypothesis is?
They are kind of tentative plausible assumptions that are tested.
Mr. Molly.
Hello.
Okay. He said they are what?
They are tentative plausible assumptions that are tested, that are put to test. So basically they are research questions that are put to test.
Mr. Molly, that's taking us to a very big English level. Assumes.
Assumptions. Okay. Assumptions.
You see, we are from the local, the village. So if we say assumption, then we follow.
Well, okay.
Don't allow. Don't
use a statement.
Okay.
Statement is better for us. That is it, okay. Proven or that has been proven.
Oh, okay. That's okay. So we can say that basically, ladies understand English more than men. True or true?
True or true?
It's
true.
hypothesis. It's hypothesis. So that is hypothesis. They are assume statements that are actually stated that we need to prove it and then come to a decision point, a conclusion decision point, whether it is true or it's not true. So hypotheses are mostly assumptions And they are something that guide our research. Hypotheses mostly guide our research. Without hypothesis, your research is somehow not complete. So hypothesis actually guides us in our research. So today we're going to learn it, and then we'll test it in STATA. We perform some tests in STATA and then see how it can be done. Basically, we can perform hypothesis with just one single sample, with a single sample, or with two samples, with multiple sample, with single sample or multiple sample. So today, we want to just understand. Now, there are about 5 basic steps, or some literatures will tell you 7 steps, some literatures will tell you 3 steps, some will tell you 11 steps to testing of hypothesis. But today we want to look at 5 tests and steps. And all these tests are common to all literatures. Okay, they are common to literatures. The first one there is that step 1, state your null and alternative hypothesis. First of all, you have your research. You have your research. That, let's say we are talking about men and women, how men speak good English and women, how women speak good English and men don't speak good English. Maybe that's our thesis title. That's our thesis topic. And we want to test whether it's true that women speak good English than men. Anyway, they will always challenge us and we'll give them the alternative to win. So after developing your initial research hypothesis, that is the prediction that you want to investigate. So in research, we investigate issue, or we investigate based on parameters. So after developing your initial research hypothesis, the prediction that you want, it is important to restate it as yes or no. We can state it as a null or the other way, either a negative or a positive way. So we state the null hypothesis, okay, and also the hypothesis, so that you can test it mathematically. Now, those in management, those in computer science, those in food science, those in material science, those in all other departments, or every school that you find yourself in, every research field that you find yourself in, you have to test your hypothesis mathematically. Those who do a visual analysis, they analyze video. They analyze video, like somebody want to analyze how people, what causes people to be happy, what causes people to be sad, sadness, or whatever. You test it mathematically. The alternative hypothesis is usually your initial hypothesis that predicts a relationship between variables. The alternative hypothesis is usually your initial hypothesis that predicts a relationship between variables. This one is just a tutorial, and then after the tutorial, we'll go to the practical. Okay. The null hypothesis is a prediction of no relationship between the variable you are interested in. The null hypothesis is a prediction of no relationship between the variable you are interested in. I'm an economist as a mathematical economic side, so I can say that mathematically there is economic growth. I can say mathematically income negatively affects economic growth. Or I can say mathematically, I can state it that say that production negatively affects economic growth, but that is not the relationship. So we can move in that direction. For example, I have an example here. The null hypothesis says that men are on average not taller than women. Okay. Men are on average not taller than women. Men are on average not taller than women. Men are on average taller than women. That is the alternative. So the opposite of what I'm saying becomes the alternative. Now, after stating your hypothesis, last time, the beginning of the lesson, we talked about data. So after stating your hypothesis, you collect data. For a statistical test to be valid, it is important to perform sampling and collect data in a way that is designed to test your hypothesis. So you see here, collection of data also is involved when you want to test your hypothesis. And then basically, because you are going to run analysis, it is assumed that you already have your data ready. Especially those who go for primary data. It is very, very important that you test the hypothesis per each of the variable. One sample, single sample. Let's say you are collecting the data for teachers, how teachers teach mathematics in basic school, how teachers do this. Each of the variable that match or each of the construct that define a teacher, you should test the hypothesis on that data individually. See, so to test difference on average high between men and women, your sample should have an equal proportion of men and women. So now, this is how it is. If you want to test hypothesis and the alternative hypothesis, if the data for men are up to 200 samples, the data for women should also be 200 samples. The data for men, if they are up to 200 samples, the data for women should also be 200 samples and cover a variety of socioeconomic classes and any other control variable that might influence average height. So anything that will affect the variable testing, you should collect data on that. You should also consider your scope. The scope, the scope, I mean the surrounding, what account to that, what lead to that, all of that variable, all of the antecedents that will constitute, you should also consider that before you test it. It is very important that I will reiterate it here that it is important that you test hypothesis. You test the hypothesis on each of the variable. If you're able to do that, the rest you will be informed what you're about to do before you go and test it on one or the other. You go and test it one or the other. Now, then the 3 steps is to perform a statistic test. Now you have to perform the test. Now there are a variety of statistical tests available, but they are all based on the comparison of within group variance. There are a lot of tests you can conduct. When you want to test hypothesis. Basically, all the most common that we do is the t-test. The t-statistics, the t-test. Okay. Now, here they are saying that look at the difference within group variance. The variance. Last lecture, when we talked about variance. Okay, we talk about variance. So I believe we are up to time. We might not go back to that. And then the within variance and between group variance. Okay, how different the categories are from one another. How different the categories are from one another. How the category of men are from the category of women. If we say women are taller than, on average, women are taller than men, or on average, women are shorter than men, how different the variance are. This we are stating. How different is it from the other one? Now, if the between group variance is large enough that there is a little or no overlap between groups, then your statistical test will reflect that by showing a low p-value. Now, I want to draw here small. They say if you are testing your hypothesis, they say if the between group variance is large enough that there is little or no overlap between groups, then your statistical test will reflect by showing a low p-value. This means it is unlikely that the difference between this group come about by chance. So when we go to the theory, the practical, you will see what we are talking about. We will see it in the practical aspect when we are doing the test. So it is also important that we take into consideration, we take into account the difference in the variable. Alternatively, if there is a high within group variance and low between group variance, then your test will reflect that with a higher p-value. So you see the difference is clear here. If there's a large difference and enough difference between the within group variable, you have low p-value. If there is a large group difference between within group variable, you have a high p-value. When we get to the practical aspect, you see, this means that it is likely that any difference you can measure between group is due to chance. Your choice of test will be based on the type of variable and the level of measurement of your data collection. Remember here, selecting the test to perform, selecting which type of test to perform would depend solely on the type of variables and the level of measurement of your variable or of your data collection or your collected data. So those who go or who deal with primary data, your test depend on the data you collect. But those who deal with secondary data, it is undeniably going for a T statistics. Basically, that is basically. So I think we must at the end of the day remember or know how to which test we are going to take, which test we are going to conduct. So I will. By the way, any question? Okay, can we go on?
Yes, doctor.
Okay, all right. So
Yeah, what of F test?
yeah, F test is also there. F test is also there, but basically we deal with the T test. The F test can also give you a good suggestion, So the selection of the test also depend on the data, as I said earlier. Now, then after running the test, you see, the fourth step, decide whether to reject or fail to reject your null hypothesis. Decide whether to reject or fail to reject your null hypothesis. So after we finish the test, the result will tell us whether to reject it or not to reject it. Okay. Based on the outcome of your statistical test, you will have to decide whether to reject or fail to reject the null hypothesis. In most cases, you will use the p-value generated by your statistical test to guide your decision. In most cases, you use the p-value. You use the p-value generated by your statistical test to guide your decision. And in most cases, your predetermined level of significance for rejecting the null hypothesis will be between 0.05. That is when there is less than 5% chance that you will see this result if the null hypothesis is true. You see, we're talking about significant level. You see, the p-value, your predetermined level of significance of rejecting the null hypothesis will be 0.05. Those that do regression analysis, those that perform regression analysis, Some fine, go for, they perform the regression analysis, and then they decide to reject their hypothesis just based on the beta value. Okay, and because the hypothesis stated that men are on average taller than this, so when they calculate the p-value is like this, and so I reject the hypothesis because we say it's negative. Yes, it's also right. It's also right, but you need to have a deep information to stand on to reject your hypothesis. In some case, researchers choose a more conservative level of significance, such as 0.01, which is 1%. This minimizes the risk of incorrectly rejecting the null hypothesis, mostly type 1 error. I'm not sure that Johnson is on the page. Would have tasked him to explain to what type 1 error is. Type 1 error is mostly you rejecting the hypothesis based on what you just said. Just based on what you just said, without performing a high level, because you are afraid. You see, you are afraid. So you set the confidence level at a high rate. Confidence level at high rate. By saying setting the confidence level at 99%. But when you set the confidence level at 95%, your p-value should be 0.05. But if you set it at 99%, it should be 0.01, which is 1%. You see, which is some mostly biased. It's mostly biased. Sometimes when we are reviewing papers and we see some people, I don't know whether by trying to prove to the reviewer that you know mathematics in your work. So, hey, my confidence level at 99. I mean, that paper, I will request for the data, calculate it myself, and then tell you to go and do major revision. Though I will not reject the paper anyway. So don't be afraid if you are selecting a journal that you by chance on me as a reviewer there. So do the right thing. Let's do the right thing. Let's be confident in doing the right thing. Now, some example of hypothesis. If your analysis is of a different in average, higher between men and women, you find that the p-value of 0.002 is below your cutoff. Sometimes you calculate and then your p-value is at 0, is below, is far below. Say 0.002 is below your cutoff of 0.05. So you decide to reject your null hypothesis of no difference. You reject you of no difference. That is, if you state your hypothesis at a higher level, or we are agreeing that the cutoff point is 0.05, and you realize that you have 0.00. It's below. It's below. There is now a question of, in hypothesis 1, either the test you perform is one tail or a two tail. Okay, so my ladies and gentlemen, let's be guided on setting the level of confidence. Let's be guided setting the level of confidence. Okay, so in this, the final step is present your finding. Present your finding. The result of the hypothesis test will be presented in the results and discussion session of your research paper, discussion, dissertation, or thesis. Basically, after you finish your hypothesis testing, I see some papers, they'll do the analysis, create the hypothesis, and then present the hypothesis on a different hypothesis testing on a different page. Some put it at appendix. You see, it's good. you've gone a step beyond, you have transcended the normal presentation of your results. So it's important that we actually work on how we present it. Yeah, I will pause on the tutorial here, then we'll quickly dive into the analysis aspect. Any question?
Hello, sir.
Comment? Yes,
yeah,
sir.
please, mine is not a question. I was trying to take down the notes on the step 4, but you went ahead, and so kindly go back.
Okay, step 4.
Yes, please.
All right.
Yeah.
So decide whether to reject or fail to reject your null hypothesis. Ladies and gentlemen, I want to believe that this training we are doing will help us to go a long way to polish our write-up, and then to present our results in a way that is properly accepted. And then I also want to admonish that if you are almost writing your result session, or the result session of your thesis, of your paper, please pay attention to the little things we say here, and then you can actually pick it up. So and be open to ask questions. There are a lot of scholars on the page. They will answer you. Can I move on, Mr. Edu?
Yes, please, sir.
Yes, sir. Madam Joan, please, you can ask your question.
Please, you mentioned the confidence interval. So the standard one that we are supposed to use is the 0.05.
Yes.
Oh, okay.
Which is to be supported by literature.
Oh, okay. And the other one is also supported, but he said we should
Yes.
use the plan.
Okay. You see, let's do this analogy. Okay. You know your daddy is going to give you money. Your daddy always give you money, right? So
Yes,
you are
please.
95% confident that he'll give you money. You are 95% confident that you give you money. That one, and somebody who is 99% confident that you give the daddy will give you money, my daddy will give you money. Between these two, okay, let's say you and I, I'm 99% confident that my daddy will give you money, and you're 95% confident that your daddy will give you money. Between the two of us, who is more likely to receive money?
And the 99%.
Yes, 99%, which means that obviously your father will give you the money. You see, so if you put that statement in a thesis, and I notice that it's obvious. Why do I have to test? Why do I have to test this thing? It's obvious. So I think it's important that you set the bar.
Okay.
Now there's an announcement on the page that we should kindly scan and fill in your attendance. Thank you, Madam. Yes, Madam. Yes, Madam Gertrude.
With the question that the lady just asked, I want to add a little bit to it for her.
Add it to her.
Okay, so the 95% confidence is usually the default, like that is always advisable to use, because with that one you're just giving a 5% margin of error. Do you get it? So if you use a percentage that is much lower than 95%, maybe like 80%, it means that the results that you are coming up with, you are not even sure of your results. It means that any reviewer or anybody that will look at your work with the results and see a very low confidence level will feel like probably you have a problem with your data, and then your results, you are not so sure or so confident with your findings that you are coming up with. That is why it's always advisable to use the 95. So thank you very much for the opportunity, Doc.
Yeah,
Thank you.
Yes, I'm learning. Somebody is also talking. There's a statistician on the page. I'm not seeing him today. Please, someone should look for him for me. My brother.
Johnson, right? I just tested him.
Yes.
He will join.
In fact, and I can see Madam MFA is on the page. MFA. Okay, Johnson just joined.
Johnson is there. Johnson is there.
Hey, my brother, tell us something. No? All right, so okay.
Thank you, Dr. K, and our colleagues. Dr. K is already on point, so yeah,
Hey,
I'm happy for that.
This is a big pressure. All right, so we okay, Mr. Edu, can we move on?
We can move on, Doc.
All right.
Yes, please, I'm done.
All right.
Thank you very much, sir.
So I said we need to be careful with our result presentation. We need to be careful with our result presentation as well. So yes, we should be careful with our result presentation. Let's not just jump to do anything we want to do. Let's be guided. Now, I want us to do let's try and do some study. I have something here for us to study. As I said earlier, hypothesis testing is the process of data utilization to test a hypothesis about a population. And it's mostly advisable that you don't have to wait till you perform the regression analysis before you run the test for the hypothesis. You can actually test the hypothesis on each single sample, each parameter, each variable. Okay, so I'll go ahead, and then please let's now go for the STATA. Let's go for STATA. Let's launch our STATA, and then we call in the data that we are we together? We'll still run with that same data that we used. Hey, someone sent me a message. Okay, I'll talk to the person backstage. Please launch your speaker. Yes, please.
So before we zoom in, I want to find out the last time after we're done with the what we did the last class. Later I tried to save what we did, but I couldn't save it. So I don't know.
I think Dr. God bless did the recording. I think he posted it on the page as well.
Not basically the recording, about what we did, the analysis we did in the STATA. I wanted to save it as a file, like just to try and save it as a file or something like that. But I couldn't save it.
Oh, but when you are about closing, it will tell you that save or not save. Did you see that?
Yes, I saw that. I did, and it couldn't save.
Oh, but when you click the save, you have to save it in a file, in a folder, so that next time when you go there, when you come to STATA, you can call the result.
Oh,
you see, when you go to the file side,
yes, Doc.
right?
Yes.
Then you can import your result from there. You can import your result from here.
Okay, Doc.
Let me share my screen for you to see something.
Okay, Doc.
So you see, at this side, you can go to the file.
It's still loading, please. It hasn't come.
Oh.
It's in now.
It's in now. I think it traveled to Shanghai. Now it's back to here. So you can go to the file here. And then because I don't have a saved result here, you can go to the file here and then you call. You can also go to the open here and then you can call your result. Here, you can call your result. You can print it by saving. So you can call it anytime you want to from the file here, edit, you can call your result from there. So next time, do that and then we will see. Now
Okay,
let's call our data. You remember the procedure of calling data? All right, so we go to file, imports. If the data is in SL, you take it from SL. But if the data is already saved as a STATA file, we just go to open. You see, for example, here, I come here, go to open. You see, I go to open, it's giving me a folder here. All these things, you can see the interface that open here. This is already so this data are already in the system. So if I click like this and I open, it go. But we are not using that, so I will not go there. So it's good when you save your data there. But if you didn't save your data, you don't save your data there, you go to file, import SL, and then locate where your data is. Locate where your data is. Already my data is at okay. I've been making guys see that. Now, are we together? Now you notice that when you open your data, you can still see the data well arranged, well clear. Normally, everything is okay. Now, before we proceed, I want to teach us something. You see, when you open a data site, you see net export is full of negative. Did you see it? Okay. Now, in case we want to transform this data, it will be impossible for us to transform because when you transport net export to a logarithm level, we'll have over 40 something missing, which is not what we need. So please remind me before the class ends, I'll show us how to drop it, how to correct that. Now, how do we perform a testing of hypothesis? Testing of hypothesis. There are several ways to perform it. You can either go to statistics here and perform it here. See, perform it here, or you can as well perform it by typing. Now, generally, you can just say type t-test. T-test. Let's call variables. Let's call variables. You see, when we just call these two variables, it didn't work. So what we do is that we issue the command that this variable is exactly as this. Now, I will take my time again and I will do it for us to see. There are ways of doing it. If you want to perform t-test of testing hypothesis in the data, in the variable, on the data, one sample, you can as well issue a command or go to the drop-down menu and perform it. Going to the drop-down menu to perform it help you to perform just one tail statistics. One tail statistics. Now, we can as well just decide to say that if we say t-test is equal to 0, t-test is equal to 0, we need to issue a parameter. We need to issue a variable to say that t-test equals to 0. So normally what we do is that we go to the drop-down menu, go to summary statistics. Are we following? Summary and descriptive statistics. Then we can perform a general one-step variable analysis. You see, we have the multivariate tests of mean, covariance, and normality. We can also perform t-tests from there. We can perform distribution plots and tests of the t-test here. We can also go to non-parameter tests, but basically to perform the t-test of one sample, we go to the non-parameter test of hypothesis. Or when you go to the classical test of hypothesis, we have t-test mean comparison of t-test calculation and all these things. So to perform the hypothesis, when you come to the drop-down menu, you have a non-parametric test of hypothesis. And I said earlier that it is important you test for the hypothesis in each of the variables. So let's go to one sample test. One sample test. Now, at the one sample test, we call for the variable. Which variable are we testing? We can pick only one of this and try and see, okay, it doesn't work. Which means that the syntax, let's now go to why is this, it didn't work. Now, if you have that same error, please, somebody should just read what actually is the problem. Madam Joanne, what do you think is the problem or is the reason why it didn't work?
All item in this list. We should have typo. I think maybe the typing error or something.
This one, is it typo?
Yeah, I don't know.
Madam Joanne, you asked this question last week, right?
Yeah.
Yes. Are you sure you didn't ask? Yes,
Oh.
anybody to help us? Why is it that it didn't work? Madam Maureen.
It is saying that it is invalid syntax.
It's invalid syntax. Invalid
And
syntax.
at least we need to have two variables.
Okay, we need to have two variables. All right. So now let's go back to perform it again. Now we still go back to the descriptive statistics, then the mean, and then the non-parametric test. The classical test of hypothesis, the t-mean comparison. Now you see when this dialog open, the interface open, we have one sample, two sample using variables. Now we just want to make one sample variable. Now we just want to test for only TFP. But before we test for the TFP, we need to calculate the mean. We need to calculate the mean value of TFP. So let's perform descriptive first on this one. Now, please, everybody should perform the discrete statistics first here. Using total factor productivity, GDP growth, export, import, and net export. Then we can calculate the T statistics of the variable. Then we go back to the statistics side, go here, and then come to the classical, and then the T test. One step, one sample, and then we call in the variable you want, total factor productivity. And you see that here, it is asking you the hypothesized mean. Which is, we are talking about total factor productivity, TFP. The hypothesized mean of TFP is what? 3.475694. Then we call it. Then we submit. We submit. Now, when you are running the t-test to check whether the hypothesized mean of total factor productivity, that all the variables or all the constant down form total factor productivity, they are biased, they are negative, whatever. There are two things, or there are a lot of things we need to look at for. Number one here, we see the total observation is what? 45. The mean is this. The standard error is this. Standard deviation is this. And we see it's at the confidence level of 95, which underscore our 0.05 level, which is the cutoff point that we established. Now, you see that the result is giving you the T statistics, which is 0.0001, and the degree of freedom of 44. You see, degree of freedom of 44. The hypothesized mean is 3 point this and this and this. And then our p-value here is 0.0. P-value is 0.999. Now, the most important thing we are looking for here is the p-value, the t statistics, and then the p-value. T statistics and the p-value. This is going to be our judgment or our decision point to either reject that the TFP variable or the data of TFP is most basically biased or is unbiased, or the constraints that form the TFP are biased or they are not biased. Are we together? Again, I'm saying that for us to take a decision, our decision point will be based on the T statistics, and then the p-value here. The p-value here. Now, the cutoff point here is that if the T statistics is lower than the p-value, we fail to reject. If the p-value is higher than the T statistics, we fail to reject. Mr. Johnson, senior statistician, any contrary view on this?
Oh no, that's exactly what. Thank you, Doc. That's exactly the point. That's exactly the point you're making. Today, pardon me. That's exactly the point you're making.
Okay. Class, Mr. Johnson said we should pardon him. We are going to pardon him, but if people we will call him every day. Now, so as I said in the tutorial, I'm calling the tutorial back. I said that the cut of our decision point, say decide whether to reject or fail to reject the hypothesis. I say in most cases you will use the p-value generated by your statistics test to guide your decision. In most cases you use the p-value generated by the statistical test to guide your decision, and in most cases your predetermined level of significance for rejecting the null hypothesis will be 0.05. That is when there is less than 5% chance that you will see this result if the null hypotheses are true. Now you see that. So from this point, 0.05, and then our result, which is 0.999, and our T statistic is like this. Are we to reject the null hypothesis or accept the null hypothesis? This is to the class. Judging from this, in most cases, your predetermined level of significance of rejecting the null hypothesis will be 0.05. That is when there is less than 5% chance that you will see this. Okay. Now, judging from this p-value and the result of this p-value, Mr. Edu,
hello, sir.
What's your take on this?
Yeah, my take is we can't reject the null hypothesis because
we can't reject the null.
Yes, please. Yeah, because it's 0.99, which is almost 1, which is higher than the 0.05.
Okay. This is not 1. This is almost multiply that by 100.
Okay, 0.99. You let me.
All right. Any other take, Madam Joanne? What's your take? Assuming you run this and you see this result, what's your take on this? Sorry, I will disturb everybody in the class too. Let's make the class interactive. Madam Joanne.
So
yes, what's your?
This is not 0.05. It's insignificant.
So what do you say? You accept the null hypothesis or reject the null hypothesis?
No. So you reject. What? Huh? You
Okay,
reject.
I have second view. You will reject. Okay, so Madam Maureen, from your point, what do you think we should do? See the class.
Hello, Doc.
Please.
Mine is not to reject. Mine is to accept the null hypothesis.
Okay.
Yeah.
Yes.
Okay.
Somebody
Doc,
also
permit
talking.
me. I want to.
Come
Here
in.
is Johnson class. Please, I
Okay.
want to say that. I want to add that most often we reject the null hypothesis if the p-value is less than 0.05. That's 5%. So
Yes.
looking at this is where we make the decision. Looking at our current p-value compared to the hypothesis or the default p-value, we fail to reject the null hypothesis that the population hypothetical mean is the same as the sample mean. Thank you.
Exactly.
I'm done for the day.
Exactly. You are not done. You are not done. You are not done. So, ladies and gentlemen, you see, I want us to get this clear again. You see, the p-value, it's more than 0.05. So we cannot reject the null hypothesis. Rather, we accept the null hypothesis. We accept the null hypothesis. On the other side, let us look at the T statistics. Let's look at the T statistic. The T statistic is even lower than the p-value. So if you are confused, just compare the two. Compare the T statistics and then the p-value. The one that is higher and 0.05, then your decision is to accept the null hypothesis. Let me hammer here again. If the p-value is higher than 0.05, now remember our confidence level here in the result is 95, which is general, which is the cut-off we are using. The cut-off we are using. What happened? What if we decide to change the confidence level? Let's try and change the confidence level here. You see, let's change the confidence level to 99. There's no difference here. I think let's take it a bit higher and see. Let's put the confidence level as 80. The value is the same. You see, I should have used unpolished data for you to see the difference. But it's the same here. So you can see that the hypothesis we state that the variable or the constants or the parameters that form the main TFP variable are all biased. The null hypothesis is biased. So we accept the null hypothesis that they are not biased. They are correct. They are correct. Now, I want somebody to, we should try, let's perform another one. Let us use another variable. Now, let's use that of GDP growth. Let's use that of GDP growth. Remember, the mean value for GDP growth was 4 point. This is the mean value for GDP growth. Now, with this result that we are seeing here, are we to reject the null hypothesis that states that the variable, the constant of GDP growth are not biased? Which the alternative say that the constant that form the GDP variable are biased. Based on this, Madam Joanne, are we to reject the hypothesis?
Where is the p-value?
The p-value
Okay.
is this.
Yes, so you fail to reject the null hypothesis.
We fail to reject it. What the basis?
Because the p-value is not 0.05, it's not less than 0.05. And also, it's also, the t-value is also less, very less than the p.
Okay. Mr. Collins, I'm going to run analysis on something now, and then you tell me your position on it. Please, ladies and gentlemen, this particular aspect of testing, whether it is statistically good, is important in our thesis writing and also in our paper writing. So, Mr. Collins, I'm changing the observation to export with the mean value. Good. This will now generate some issue here now. So, Mr. Collins, what's your take on this result?
I think that the t value is equal to 0, and the p value, let me see, p is also 0.500, which means that, of course, even with the t value that is 0.00 raises a lot of questions. And then the p value is also greater than 0.05. So I think it's insignificant. So should we be testing the hypothesis? Let me see the mean. So if in case the hypothesis is to maybe if you're testing, let's say, the fact that export is greater than maybe a particular mean, then I guess based on the result, we may disagree with maybe that hypothesis and maybe go for the alternative hypothesis or something.
Okay, Mr. Collins, thank you for your contribution. All the answers you give there, they are good. We established the ground that we are just testing the variables, whether the construct that form the variables are accurate, are right. There's no bias, there's no ambiguity in it. And we established that if the p-value, which is this, right, is more than the t statistics, we accept the null hypothesis. Though we don't even go to the alternative hypothesis. And from the look of things, we add a cutoff point of 0.05. And you see that this is more than 0.05. So it is not right to accept, it's not right to reject the null hypothesis. So we accept the null hypothesis. This is just the test we are conducting. Thank you very much.
Please, I have a question.
You can ask your question.
Please, you mentioned that for this, so the null hypothesis is that the value is biased.
There's no biasness in it.
There's no biasness.
Yes.
Oh, and the alternative means there is bias.
There's bias. Yes.
Oh, okay.
Yeah.
So this one is like when you are using smart PLs, it's like you are checking is it the Cobalt alpha or something?
Combat alpha.
Yes. Of
And
each
then
variable to see if, yes.
That you're talking about validity or fatal loading of each of the variable, right?
Yes, for the variable.
You do fatal loading of the variable, and then you take the comeback alpha to justify that, which should not be less than I think should not be less than 5 or something.
6 or something. Yes.
Yes.
So it's like here we are checking to see if each variable, like we can go ahead with a hypothesis, the full hypothesis. Okay.
Exactly. Thank you for bringing smart PLS structure equation modeling in here. We'll run the structure equation model with the STATA to assume. Now, let us also try. There is a way we can also do a t-test. Okay. And we set the hypothesis that, okay, we run a regression analysis. And we want to check if the boys, let's say, number of, okay, let's use our data here. We say import, right? Imports have a negative impact on total fatal productivity, or import negatively affects TFP, right? TFP. So only the TFP and then the import. TFP and import. We can test it here by saying that T-test TFP equals to import. Now, let us try something here. Again. We want to test between two variables. Let's say TFP and import. And the hypothesis that we are setting, the null hypothesis we are setting, that we agree that imports negatively affects TFP. Import negatively affects TFP. We are not using a direct regression analysis. We want to use the t-test to test this hypothesis. Now, you just type a command in the system at the command bar. Let's all type the command. Just t-test, t-test. Now, what is the dependent variable? TFP is the dependent variable. We call the TFP, and then a space. Now, we are testing if import negatively affects TFP. So the issue is exactly import, not any other. These two variables. And to be specific or exact, we use 2 equal sign. And then we call the variable. We say import. And then we click enter. Please, who has performed his analysis? Now, from the result, the output, we can still see the mean value here, the standard error, the standard deviation, and then the confidence interval. And now, look at our T statistics. Our T statistic is negative 13.9449. And then our p-value is 0.0000. 0.000. Now, judging from the premises of this statement, the null hypothesis, rejecting the null hypothesis will be at 0.005. And this result, are we to accept the null hypothesis, which states that imports negatively affects TFP?
Yes, please.
Okay. Looking at this result we have here, and then the alternative hypothesis states that imports positively affect TFP. Which of the hypotheses are we going for to make what would be our decision point here? Our decision, is it to accept the null hypothesis that allude to the fact that import negatively, or the other hypothesis? Madam Joan, as your mic is open, please tell us what's your decision here and why are you going for this decision?
Since P is greater than the T value, then we fail to reject the null hypothesis.
Okay. This is two variable. It says since P is greater than 0, the T, then we fail to reject the null hypothesis. Okay. Any other contrary view?
But it's also significant. So me, I don't.
But it's also significant. Mr. Edu, Edu, please tell us something here.
Yeah, I would say we have to reject.
Okay, your condition?
Yeah, if I'm not getting confused, if it's less than the interval, confidence interval, then we reject the null hypothesis. So in this case, as is 0.00 is less than the threshold of 0.05. So we reject the null hypothesis.
Okay.
Yeah.
Okay. Any other view? Please, any other view? Mr. Collins, your view, please. Mr. Collins, your view on this? By the way, is 0.000 greater than negative 13.9449?
Yes,
yes, please.
Doc.
Yes, sir.
Thank you for the opportunity. I think one of the sometimes this decision making is not necessarily based on the p value or the t value. as you can see from the descriptive statistics, the mean,
Mm-hmm.
the TFP has a mean of 3 point on an average of 3.4 compared to
Import.
36.244.
Yes.
So that is also another way to make these decisions. Thank
Mm-hmm.
you.
That is using two variables. That is using two variables. Okay.
Yes.
So, Mr.
Please,
Collins,
I didn't hear what you said.
Mr. Johnson is saying that we can also base our decision on the mean value of TFP and import. You see, it's clearly mean of TFP is 3.4 and then mean for import is 36. Okay. We can also base our decision on this. Now, this result is going to lead us to go and run the regression analysis. Basically, in econometric level, when you notice something like this, and you see the mean value like this, and this like this, then it will push you to go and run a regression analysis to either accept the stated hypothesis on the thesis or on the paper. It's obvious that this is higher than this. Or am I wrong? 0 is higher than negative 13.9449.
You're right, sir.
You're right.
Okay. All right. But our threshold point is 0.05.
Yes, please.
So let us run it to support our decision whether we accept the null hypothesis, because on the faces of this is higher than this. On the general phase, this is higher than this. So the null hypothesis can stand. But let's run a regression analysis. Yes, Mr. Johnson.
Dr. K, please. Let me draw attention to something.
Okay, sir.
When you look at when we look at the interface, you see that we're having three different probability values.
Yes.
The first one, we have the mean difference, which is greater than 0. And the second, the middle one, is also talking about the mean difference, which it says is not equals to 0.
Yes.
0. And the last one, which is also talking about the mean value, there is 1.00.
Yes, 1.00.
You see. So I want to suggest that one of the key things in terms of this is also looking at which to report.
Which to report, that's it.
Yes.
That's it.
That leads to the regression analysis Doc was talking about. Thank you.
So I was actually basing on this whole thing because when you check from the start, we base here and here, right? We base here basically, and we're not looking at this because there's no point looking at it since we have the P here. But when you come down here, you will see that the first, second, and the third. This sign say what? The mean difference. This one, the first one say the mean difference is what? Greater than 0 or less than 0?
Less than 0.
Less than 0. And here the mean difference is what? Greater than 0. So this here, this information here, and this information here, and this information that we are seeing here, will now push us to run a regression analysis to authenticate whether we reject the null hypothesis or accept the null hypothesis. Are we together? Are we confused? Hey, silence me, you are confused.
Hello, sir.
We are together with you. I knew we are together with you.
Hello, sir.
Yes, sir, please come.
Yeah, please, if I heard you right, you said the nile is import negatively affect
yes,
TFE.
Yeah.
Okay. Okay. And the TFE is the dependent.
Dependent. Yes.
Okay. Okay. Thank you, sir. That was the clarification I needed.
Yes,
Maybe
Madam
I
Joy.
was thinking the
Yes, please. Please, Madam Joy is coming. Let Madam Joy speak. And then the next person will talk.
yeah, so like when you said we are going to run the regression analysis, I thought that's what we are already doing. So the T test is different from we cannot use the T test to show the relationship.
This is no regression analysis, please. Regression analysis is different. Yes, another person, someone was also talking.
Okay, I can come in.
Yeah, please come in.
Something I wish to understand is that, like, for example, if you are writing a thesis, some of the reviewers they can maybe request for you to show the t-test as well as regression. So I want to ask a question is, if I do the t-test alone, is it not sufficient to maybe explain the relationship? Or in that order, should I like run the t-test and then keep the explanation for the t-test and then go ahead and also run the regression analysis?
Okay,
yes,
so fine. It's a nice question. You see, when you run the t-test, okay, you are testing hypothesis as well. You are as well testing the hypothesis. But the regression analysis is a step beyond the t-test. Now, the regression analysis tell you the exact impact of the variable, the independent on the dependent. That is where we get the beta value or the beta value, and we get the alpha value. Now, the beta value tell you as the exact impact. The beta value tell you the exact impact.
Like
okay. OLS, DOL, F, fully modified model, tells you the exact impact. But this is that we are not seeing any exact impact on the anything here. Do you notice we are not seeing any exact impact here?
Yes, please.
We are only looking at the hypothesis whether this actually there's actually an issue to deal with.
Okay,
Madam, are you okay?
I can come in again with a question because we are not seeing any impact. Since we are not seeing any impact on t-test, does it mean that it is not necessary to run a t-test?
It's necessary. It's necessary. The impact we are talking about, we are not seeing the impact on the independent or the dependent. This doesn't show any impact here. Please, let's run a regression and you see the difference. Let's run a regression. Let me do a regression analysis and you see that.
Okay.
Dr. K.
Yes, please.
Please, the house, thank you. I want to add that ideally, t-test is not to test the relationship between two groups.
Yes, exactly.
It is to test the difference in mean between two observations.
Yes, please.
Okay, so actually, when we test the difference between variables maybe import and then TFP, we are looking at we call it PET sample t-test. PET sample t-test to see if the mean the observations in mean are different, or there's a mean difference between the two variables.
The two, yes, please. Yes, please.
Yeah, I can hear you.
Yeah.
What t-test does.
Please, he has done it for me.
Thank God.
Hello.
Yeah, hello.
Yeah. He said your time. They used to type it. They type your information into the system. So right now that the system is the one to put it in.
Oh, Mr. Collins.
I've muted him, so it's fine now.
Okay, it's right now. Okay. Now, let's you
No,
see
Prof. Johnson, can you come again?
Johnson's view is Johnson's also is adding to. Okay, Mr. Johnson, please come.
Okay, Doc, thank you. What I'm saying is that actually a t-test is to test two or more.
To
I
compare
think this
mean.
one. Comparing mean of one one sample to a hypothetical mean, or to compare mean between two observations. This is what a t-test does. So what Doc is doing here is what we call the paired sample t-test, because we are comparing the mean of two different samples. Which is the TFP and the import. That's exactly what we are looking at here. So the t-test doesn't tell you the relationship between a dependent variable and an independent variable. In other words, a response variable and then a predictive variable, just like Doc said.
The
Thank you.
variable. Yeah. Yes. So you see, when we're doing the t-test, testing the hypothesis, we're saying that the variable, there's no biasness in it, or it does not contain zero. Okay, the TFP does not contain zero, or there's no biasness in it, and the mean is what we are trying to check here. You see, so when you come here, you see the classical test. You say t-test mean comparison test. You see, we are just in one test, mean comparison test. So we are testing the mean. If this actually, the variables that constitute the TFP has zero in it, or is biased, or it's not fit for purpose, the mean will tell us it's not fit for purpose. And then we went ahead to test, actually, is it true, this mean that we are having, is it true if we use it to run the analysis? If we try to use this variable to run analysis, our decision, our final decision, will it be concrete? Will it be solid? We compare the mean, we test the mean. So, Mr. Molly, are you clear now?
Oh, yes, I didn't hear what he said. That is why I'm clear. Thank you.
Oh, okay. So those who are talking about the regression analysis, which will be our next topic. Yes, which will be our next topic according to the schedule. Now, looking at this point here, so I will not explain anything from this side yet. I will not explain anything from this side yet. This side. I just want us to see this, whether we are accepting the null hypothesis or the alternative hypothesis based on this. So we've run an analysis, and the coefficient, which sometimes called beta value, possess zero, doesn't possess a negative anything, right? Does not possess any negative anything. So we say it does not have negative impact. So the first one, so it has a negative impact. That the null hypothesis, it has negative impact. But here, we do not see any negative impact. So we go for the alternative. There's a positive impact in it. Are we clear?
Yes.
All right. Thank you very much, ladies and gentlemen. Any question, contribution, so that we wrap it up?
Hello, sir.
Yes, please come.
Yeah, so if the coefficient was to be negative, then the null hypothesis holds, right?
You don't have to, yes. So the null hypothesis is holding. That is another decision point we want to take next time when we have our class.
Okay, sir.
Okay. So I will advise that from the next class we are going to have, those who have your data ready, you have your data ready, you want to start running your analysis, you want to start doing your testing, you can start following this level to run your paper analysis, your thesis analysis. It's a somewhere, yeah, you can start following to run your analysis, take the notes, and take the interpretation we'll give from the next lecture. Take the interpretation we give from next lecture, and then you begin to put down your thesis or your paper. All right, I'll pause here, and I'll thank everybody for
please, I have
paying
a
attention
question.
Yeah, please, Madam Joan, please ask your question.
Please, when we were doing the t-test for the PF and the no, this one, the one we just did, Dr. Johnson mentioned that when you even see the mean, you should be able to tell. Please, what's the threshold? How will I tell from the mean?
You say when you see the threshold, you should be able to tell. What will you tell the difference from the mean?
He mentioned that even the mean should help us to tell if the t-test is if it's significant or not, if it's
okay.
If the null
Dr. K.
hypothesis.
Yes, please.
First of all, let me correct. I am not doc, and I think Mr. Johnson is okay. Thank you. And also,
that's honorary.
You see, the idea of a t-test is to compare means. Okay, which we have, I think, 3 levels of doing that. We have the one sample t-test, and then the independent 2 sample t-test and the per sample t-test. So I also advise that we read a little bit about it. Now, look, we can use the mean, that's the average, to tell if there's a difference between 2 observations or 2 or more observations where they have the ANOVA, another more high tests, advanced tests, and blah 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 blah. Okay, if you look at these 2 means, you see one is very high, that's 36 point something, and the one is 3. It tells you that there's a difference in mean. Assuming this is a typical research where you have to go, I think Doc knows, and other scholars or the platform also know, they have to perform maybe the 2 case tests to test, you have to Bonfari test to prove all those existence. So ideally, as Doc rightly said, the t-test is to compare means between either one sample to a hypothetical population mean, or PET sample, a test before and after, or 2 different independent observations, as we are doing. Thank you so much.
Thank you.
Okay.
Dr. K.
Yes, please come on.
Okay, I want to ask a clarity on how to present the, like I say, the results if I'm using the STATA. Like, for example, if I'm using the Smart PLS, the first thing I should present is the summary of the data, like
And then the second thing is reliability. The third thing like that. So is what we are doing, is it in order? Like we did the summary of
Yes,
data, and then today we are doing details. So I should present them in
yes,
that order.
yes. You don't have a problem. You can present them in this order. But basically, your T statistics, you report it, and then you can put the T test like this. As we are comparing the mean in the variable, you can add it to your descriptive statistics and then write on it, or you can create a table and put it at the appendix to talk on it. I'll give you a three experience that I Journal of econometric journal, and then journal of time series, and then uh, growth and change
Okay. Thank you.
mostly. And then the criteria they give is that these things should be put at appendix, but report them in the work. Are we clear?
Thank you. Yeah.
You're welcome. Yes. All right. So, ladies and gentlemen, brothers and sisters.
Please, before we end, I want to ask. I have a personal concern.
Okay.
At the end of the class or the workshop session, are we to write exams or maybe any form of assignment to be awarded certification or what have you? If the notes
Yes.
mathematics
Yes.
code, yes. Why
Yes, this is
should
a
that
very
be?
good
I want to know.
this is a very good question, and I will direct it to Madam Irene, and then Mr. Koju. They're on the page.
Hello, Doctor.
Yeah. Yes.
All right, it's about the concern of recognition. Of course, you have to take a project from the facilitator to confirm learning has actually taken place. Then we can take it up from there.
Okay.
Okay, thank you. But I think with workshops, is it advisable? Or maybe tutorial session as this, is it advisable?
I don't
Because,
quite
for instance,
understand what you mean.
for instance, with my experience with various workshops, diaspora and domestic, you will not assign a session where you said you have to complete a particular project or assignment for recognition. The core thing is
Well, every organization with
if
their
lesson
style
has
of
taken place, yeah,
Well,
I agreed. I
can
know
I
every
come in? Every
organization they are.
organization with their own style of implementation. We want a program we want the effectiveness of this program. And so how do we assess the validity of this program? You understand?
Then I thank you. Then I think ideally at the initial stage it has to be made known to the participants.
I think we can continue with this conversation backstage.
Okay,
And
let me leave you. Okay, thank you for your time.
okay, thank you so much for your time. Please, if you have any concern, feel free to reach out to us in our personal DMs and we'll respond to you. Okay. And so
Hello, Dr. K.
Yes.
Yes, sir.
Madam Irene has not finished, so let her continue. Then I come. Mine is on the studies we just did.
Okay.
Okay, so what I wanted to add to what I've already said is to make it known to all the participants, the members of the academic committee. Aside myself, we have Professor, one of our facilitator who is called Bruce. You already know him, and Gertrude is also one of our team. member, same as Bonsu, right? And then Dr. God bless. And so we are 5 in total. Feel free to reach out to us anytime. We are ready or open to addressing your concerns. All right, so Dr. Edu or Mr. Edu, kindly take the mic and you can say your points.
Yeah, I'm now doctor in the making, so Mr. Edu for now.
Okay.
Yeah. So you made mention of some list of journals that we can see how they present the test results and all that. And I want you to come again on that so that I can note them. And
econometric, journal of econometric.
Okay.
It's ABS *1 rank, and then SSCI.
ABS
and then SCI. Yeah.
Okay.
The second the second one is time series, journal of time series.
Okay.
Also ABS, and then growth and change.
Growth and change, journal of growth and change.
Yes, SSCI. All these journals are closed access.
Okay.
Closed access.
All right, sir. Thank you very much.
And one criteria for all of them is that your thesis should have a econometric, a very solid methodological session that's others can build on. So you can consider it, and then you can.
All right, sir. Thank you very much.
Sometimes they will ask you to suggest one thing these journals they do this, especially time series and econometry, is they will ask you to suggest a reviewer. When you suggest the reviewer, rest assured, let's leave it there. All right, so ladies and gentlemen, we'll end our lesson here today. And then next lesson, the next lesson, which will be on regression analysis. So we're going to do run all that analysis next lecture. Thank you for your time. Please do enjoy the rest of the evening, the day, the afternoon, wherever you find yourself. Thank you, ladies and gentlemen.
Yeah. Thank you.
Thank you too.
Dr. K, please, the class is over now?
Yes, please.
Okay, then I think I can stop the recording.